what's about inconsistent science? The idea she was going to talk for about 30 to 40 minutes, and she will be accepting during her talk short clarifying questions. If you got any deeper question, please wait until the end of the talk. So, please, Maria.
Thank you very much, Francisco. Thank you very much, everyone, for staying. It's already late, so I'm gonna be quick. And first of all, I want to thank Luis for having all us here. This is quite a dream come true for me. I can appreciate a lot, not almost, everyone that have come to this workshop. And I'm really happy having you all here. So thank you, Luis, for that. And this is a joint work with Luis. It's still work in progress, but let's see. So in recent years, people have been claiming something like some inconsistent theories could be justifiably believed by the scientific community. I'm not gonna exactly point at that people, but many of them are here and are in the poster as well. And let's call those people the I believers. And let's call this that some inconsistent theories could be justifiably believed by the scientific community as the inconsistent science thesis, from now on ISC thesis. So, in order to support such thesis, the I believers have provided many examples from the history of science that seem to illustrate something like how the presence of some contradictions do not necessarily mean the scientific community irrationality. You can find people in this tradition from the history of science, like Lakatos, Laudam, from the philosophy of science as well, and people from the paraconsistent tradition, like Da Costa, Meheus, Priest, Diederik, and almost everyone here, or everyone here. However, some others have claimed that the ISC thesis is not actually supported by the history of science. And you can find easily people that say so from few past years, like Kevin Davey in 2014, and like Peter Vickers does in all his papers from 2012, 2002 and so on, and mainly his book from 2013. So let's call these people the I debunkers. Remember Kevin Davey and Peter Vickers at least. And now everything is I believers versus I debunkers. And the question, of course, the important question is who will win? If one leaves this question to the history of science, a more specific question has to be brought to the table. Namely, what are the sufficient conditions an alleged case of inconsistency in science has to meet in order to be a candidate to support the ISC thesis, the inconsistent science thesis? So that's a question that you have to keep in mind. That's what the talk is going to be about. And in order to answer this question, we will proceed in 4 steps. First, we will say a bit about the I debunkers, who are they and what do they believe, and their agent's irrationality argument. In the second part of the talk, I will say a bit about holism and model building and applying processes, and how all this works together, at least a bit against the I debunkers thesis. I will provide an example of how that happens, and then we will draw some conclusions. First of all, let me introduce David D. and his I debunkers friends. This is David D. He is a very cool scientist who knows all what cool scientists tend to know. For instance, David D. knows that contradictions are logically false, hence they are never true, and this is taken to be known by any scientist. As a matter of fact, he has been informed that one of the worst fates that can befall a theory is the discovery that it is logically inconsistent, because it is impossible for all the elements of a logically inconsistent set of sentences to be true. We don't even need to do any experiments to know that a logically inconsistent theory is false. This is a direct quote from Kevin Davey in his paper, Is Good Science Logically Inconsistent? So, the ID bunker's argument on agents' irrationality. It's still DVD that has been told by the ID bunkers that scientific communities have never justifiably believed an inconsistent theory, and that the appearances of the contrary should be explained away. So, first of all, what are they talking about? Well, in the ID believers literature, it is said that if a scientific theory is inconsistent and known to be so, and scientists still believe in it, the ISC thesis is the case. Or in more general terms, someone is tolerating the inconsistency, or inconsistency toleration is the case. However, because of the clear falsity of the contradictions, ID bunkers usually think the following. If a scientific theory is inconsistent and known to be so, and scientists still believe it, then it is clear that such beliefs should be rational, because the falsity or the evident falsity of the contradictions. And let's think about this as the agent's irrationality argument. This is, contradictions are logically false, hence never true. All scientists know so, as David does. And it's possible for any scientist to justify belief in things that she knows are clearly false. So, this means David D, knowing all that, if he faces an inconsistent theory, he will know that he cannot believe in it because it's clearly false. If a scientific theory is inconsistent and known to be so, and scientists still believe it, then agent's irrationality is the case. So, any questions so far? No? So, against this, any I believers that want to endorse the ISC thesis faces a double challenge of following. First, explaining how scientists can not only believe inconsistent theories, but justify believe them without they being irrational, as the agent's irrationality argument says. And second, that I believer has to provide historical examples in support of the thesis. So there are two things to do if you want to endorse that thesis. So, I believers are not dumb people. So, in the light of that, they have claimed that they can provide several examples from the history of science in order to defend the inconsistency toleration thesis. For instance, you can find in the literature that Aristotle's theory of motion has been claimed to be an inconsistent theory, Bohr's theory of the atom as well, classical electrodynamics as well, classical mechanics when you endorse inconsistencies between theory and observation, and the very famous historical examples of the perihelion of Mercury, and the early calculus, Kirchhoff's theory of diffraction, Newtonian cosmology, the 19th century physics versus the 19th century geology, if you endorse inconsistencies between two theories, and so on and so forth. So the unbelievers think that they have provided enough case examples in order to defend the ISC thesis and the no agency rationality case. However, people like Peter Vickers don't trust them that much. So in this section, I'm going to talk about the apparent defeat of the I-believers. So Peter Vickers listens to the I-believers and he laughs and says, like, wait. You can provide all these examples, but none of these cases actually illustrate any scientific community, how any scientific community could justifiably believe an inconsistent theory. And he goes in his book talking about maybe most of them, and he says something like the following. Take the ISC thesis and understand the ISC thesis as some scientific community justifying belief A and not A, the conjunction of A and not A. Second, scenarios that could help one to identify cases that satisfactorily illustrate the ISC thesis are scenarios that illustrate a tacit commitment, regarding an inconsistent set of assumptions, for instance, cases where the relevant propositions were all believed to be true, or at least where the relevant propositions we all justify believe them. So this is, if you have that scientific community justify believe the conjunction, then you can also separate the conjunction and say that justify the scientific community justified believe A, and also they justify believe the negation of A, whatever your negation is. So, given that,
better like this, or you
the problem is that life,
people won't
yeah,
be able to
life
see.
won't. I'm sorry. So, Peter Vickers claims that none of these cases illustrate something like this part. That you can get the impression of this case being the case, but when you ask, did this happen? None of those historical cases illustrate that. And so, Kevin Davis says, for many of these cases, whenever we find a logical contradiction in a body of scientific beliefs, we also come to realize that one or another of these beliefs, or at least very least their conjunction, is unjustified. That is why the discovery of that theory is logically inconsistent is typically followed by an attempt to identify and replace any unjustified assumptions in the theory. So he's trying to describe all what happens in all those cases, or in many of them. Even worse, when it has been some kind of doxastic commitment, for instance, the early calculus in the case of Johann Bernoulli, it looked like the scientists didn't really understand his own practice. Bernoulli was not reasoning with inconsistent propositions, Peter Vickers says. So who cares about what he was saying about infinitesimals? That's what we say. There may be some value in this picture, but again, we don't seem to have any historical relevance here for defending the ISC thesis. The basic idea is, even though Johann Bernoulli could have claimed that infinitesimals were inconsistent, his practice didn't show that. And so, Vickers' explanation is he didn't know what he was doing. But what he was doing was not inconsistent. So, Peter Vickers gives you all this face and say, I find your argument suspicious because I don't find a strong historical evidence for your ISC thesis. However, so it seems that none of your cases, you people, actually illustrate the movement that he is asking for. Thus, none of them actually support the ISC thesis. And people like you will say, wait, it doesn't go straightforward. If one can provide some evidence of how the distribution of justified belief through conjunction as applied by the I debunkers is not valid, one can change the score, actually. And that's what we will try to do in the next section. So far, any questions? No? Okay. So I'm going to talk a very bit about holism and model building and applying processes versus the I debunkers' irrationality argument. Some considerations on our main concern. Do you remember a start question? So far when asking what are the sufficient conditions an alleged case of inconsistency in science has to meet in order to be a candidate to support the ISC thesis, the I debunkers have said that to support the ISC thesis, it is enough that a case illustrates the following. So the distribution of the justified belief through the conjunction. And with that, they dismiss way too many of the I believers' case studies. Or at least they believe they did. But is that the only sufficient condition? Because remember, that's what we were asking for. Maybe not. So let me introduce MAMM, which is from Margaret Morrison, and the maybe not explanation. So the I debunkers' characterization of what does it mean to that some inconsistent theories could be justified, we believe, by the scientific community and its interpretation as the only legitimate interpretation depend on our being able to show that a different scenario in which the distribution of justified belief through conjunction is not the case. And nevertheless, the ISC thesis could be recuperated. So, in order to provide a different scenario and an explanation of the possible failure of the distribution of justified belief through conjunction, let's focus on scientific models. And then Peter Vickers will protest, and he will say, and also Kevin Daly, they will say, how is that all this is going to be relevant for the inconsistent science debate? Cases that do not illustrate auxastic commitment do not tell us anything about the ICs. That's something that is in his book. And he explains it this way. So the ISC thesis assures that scientific community can justify belief in A and not A. So scenarios that illustrate lack of doxastic commitment regarding an inconsistent set of propositions, such as cases where scientists reason with false assumptions, do not illustrate the distribution of the justified belief through conjunction. When just using inconsistent propositions, ex contradictione does not present anything like the problem that is usually assumed in the literature. Scientists are justified in reasoning with inconsistent propositions, precisely the same reasons that they are justified in reasoning with idealization and approximation assumptions. So I'm going to try to use that against them. Let's ask Margaret Morrison Starr, or MM, what would she believe? And she will say, but Mr. Vickers, excuse me, but I believe 3, which is the comparison between just using inconsistent propositions to idealization and approximation assumptions in science, only expresses why lack of doxastic commitment scenarios could not illustrate the distribution of justified belief through conjunction. However, I don't see how it prevents us from choosing a different interpretation of the ISC thesis, equally legitimate. So, even more important, MM will think that it's possible that 3 is not always the case. Let me say so. Why? 3 means when you're just using inconsistent propositions, as contradiczione does not present anything like a problem that is usually assumed in the literature. Scientists are justified in reasoning with inconsistent propositions precisely the same reasons that they are justified in reasoning with idealization and approximation assumptions. That quote relies on our capability to determine which assumptions from our theories or our models are in fact accurate representations of reality and which are just false assumptions that are used for merely heuristic purposes. So, if we are not always capable of distinguishing between accurate representations of reality from just false assumptions that are used for merely heuristic purposes, and the distribution of justified belief through conjunction requires as well such capability, and if another relevant condition is put forward for not consider cases where distribution of justified belief through conjunction does not hold as support of the ISC thesis, then maybe we can get something interesting about what we were asking since the beginning. So the sufficient conditions and alleged case of inconsistency in science has to meet in order to be a candidate for supporting the ISC thesis. So before going to the exam, to each part of the argument, do you have any questions? No? So in order to argue in favor of this, we'll present 2 different arguments. The first one is Morrison's argument against idealization and the de-idealization path. The second one will be a bit about holism, and we'll present a metaphor on the Rubik cube. So let me start. Models Models, like theories, tend to involve a huge diversity of statements and epistemic commitments. You are not just one type of epistemic commitments, nor just one type of statements. It is important to say that modern theory construction involves a process that utilizes abstract methods as well as visualization in building models that represent physical systems. What we can learn from that is that we have a diversity of commitments and a diversity of types of statements. It is quite common to assure that scientists have doxastic commitments regarding some of the statements that are part of specific models. In addition, common scientists like our friend David, if you remember him, tend to trust their successful models. And sometimes they feel justified to believe in the parts of the models that seem to be connected to what they call reality. So, Morrison would say the degree of approximation involved in using models and idealization can not often be determined. And if that's the case, the point is simply that given the nature of modeling and a relative inability in many cases to independently determine whether models are in fact accurate representations of reality, the distinction between supposedly realistic models and those that are merely heuristics can be successfully made only in cases where knowingly use fictional representations. This is Morrison from 2005. And thus, if someone like David E. feels himself justified to trust his models, appealing to their predictive success because it's so amazing, and he feels justified to believe the conjunction A, C, etc., the parts that are part of the model. However, sometimes David E. is not capable of distinguishing between accurate representations of reality from just false assumptions that are used for merely heuristic purposes, if what Morrison has said is just along the right lines. So, even though he trusts the whole model, he cannot distribute the justified belief through the conjunction. Can everyone see that?
Could you say why or give an example?
Oh, well, I will try to provide an example here, but well, because she has been arguing, this is a paper on the role of idealization and the idealization processes, and she has been arguing that, well, people tend to believe that when you idealize something and you know the measure that you are idealizing something, then it is easy to go back when you finish your model or something like that. That you are capable to know how much falsity you add to your model, and then you are able to take it away whenever you want. But she has claimed that that's not the case in lots of scenarios. That scientists maybe know at the beginning, but after moving a few things in the model, well, doesn't hold that much. So that's the basic idea.
But then can't they still distinguish between the false parts and the... Does it follow that they've lost the ability to distinguish between the false parts?
I believe the quid of here is that you can maybe distinguish the very false ones, but the other ones, the ones that you idealized or the ones that you abstract, those ones maybe are not that easily for you to be able to distinguish. So yeah, that's the idea. That you cannot all the time do that.
Right, okay.
So even though he trusts the whole model, he cannot distribute the justified belief through the conjunction. Any more questions? No? So let me introduce a metaphor. First of all, let's assume that empirical theories and models share at least one property, holism. And I'm not gonna go through definitions of holism, but the basic idea that I want to focus on is that when you have a theoretical description of any physical, economic, etc. system, generally involves an extensive complex of hypotheses. And more important, if you have a problem that is related to empirical data, maybe to solve that problem, the only Now, to solve that problem, the thing that you have to do is not only to move the empirical data, but to move other things from your theory or your model. Now, let's assume that before building and testing the model, scientists are aware of the epistemic commitments that they have regarding each part of the model. Imagine a Rubik cube before you start moving things. So you know clearly that each part, the color of each part. However, when they try to use a model to solve a particular problem, or when they try to make the model more accurate or more abstract or more whatever you want, they start changing some assumptions and some relations between many parts of the model. So like you do when you are trying to solve a Rubik cube. So the theoretical description of a system rarely takes place in isolation, but is instead correlated to the theoretical description of the other system in multiple ways. So you can have your commitments about something when you're doing a model, but also the other commitments about different elements are related to these ones, even though you may not want that. These correlations are of major consequence in the event of a discrepancy between theory and observation, for instance. If such a conflict arises, modifications need not necessarily start in the theoretical description of the system where the conflict was observed. Instead, correlation attempts may start with the theoretical treatment of some other system correlated to the first. So, as when you are moving the Rubik cube. Some resulting modifications of the model could succeed at saving a specific phenomenon, could be more accurate, or could have more predictive power, or could describe more realistically the phenomena or whatever you are looking for. But scientists would not necessarily be aware of the resulting modifications that were met and their corresponding impact on the initial epistemic commitments. Imagine that this is the picture that you wanted to get in your Rubik cube. So once you are there, you cannot say all this side is blue, and all this side is green, and all this side is red. So you have a mixture of things being green and things being blue and with red, and you cannot just describe one side with just one color. Thus, if David feels justified to trust his successful resulting model, appealing to their predictive success, for instance, and he justified belief A and B and so on and so forth, and if David has no full understanding of the modifications that he intentionally did to the model and all the corresponding implications, so even though he trusts the whole model, he cannot distribute the justified belief through the conjunction. Now, let me offer a few, maybe not explanations. We have suggested two different scenarios. That not every time one finds that a scientific community justified belief A and C, for instance, one is licensed to require the distribution of the justified belief through a conjunction. So the operation that the ID bunkers wanted maybe will not hold in some cases. And this could be translated to inconsistency cases. So if you have A and not A, you don't necessarily have to, or you cannot in some cases, distribute the justified belief through the conjunction. So now let me provide a quick example. First of all, I'm not going to argue, at least not here, that this example exactly recuperates an inconsistency science case, but that could be a candidate for supporting the inconsistent science thesis. So it's a case study that comes from Morrison, from a paper and her recent book on nuclear physics. So she says there are 31 models of the atomic nucleus that have been offered. Many of them are could be classified in at least 3 different families. So, and in nuclear physics nowadays, there is currently no coherent account of the structure of the atomic nucleus. And these two, the shell models and the liquid rock models, assume different things. For instance, the shell model assumes that the nucleus is a classical object and behaves like that. And the liquid rock model describes the nucleus as a quantum mechanical object. So, such assumptions are not necessary for calculations expediency, but for generating accurate predictions. And it's important to take into account that those predictions are not, you are not able to derive them from different models, from the other models. So, and it's important to distinguish between the use of non-realistic assumptions of the type found in idealizations and the use of false assumptions that you know that are not and cannot be true. So in this case, she will say that scientists cannot explain why what types of models are so successful in an empirical level, and if they are, it seems to be a conflict between the basic assumptions of the model. So you are not sure about which one has a false assumption, and you cannot dismiss it. Because if you change, or if you assume that the basic assumption of each of the models is not the case, then you will not get the accurate predictions that you're getting. So you have, in one side, the nucleus as a quantum mechanical object, and in the other side, nucleus as classical object. And you know that such assumptions are linked to scientific success, more precisely, predictive success. Thus, one can say that such assumptions are linked to our justification to trust those models as accurate descriptions of the world. And you can phrase this as a contradiction if you would like to. Now, such assumptions are linked to scientific success, as I have already said, and are linked to and the scientific success of the models is linked to our justification to trust those models as accurate descriptions of the world. Scientists do not know precisely what makes the liquid rock model so successful. They do not know why the results are so accurate. And because the distinction between supposedly realistic models and those that are merely heuristic can be successfully made only in cases where no induced fictional representations, maybe in this case, that distinction cannot be put into use. Thus, let me draw some conclusions. Our final remarks. Do you remember our initial question? What are the sufficient conditions an alleged case of inconsistency in science has to meet in order to be a candidate to support the ISC thesis? Well, remember also that any believer who endorses the ISC thesis faces a double challenge. First, the unbelievers have to explain how scientists cannot only believe inconsistent theories, but justifiably believe them without being irrational. Second, giving historical examples in support of the thesis. So we have the question, and we have the interpretation of the ISC thesis as the following. So now we have argued that it is not required the distribution of the justified belief through the conjunction. So you can explain how the distribution of the conjunction is not the case in some scenarios. And we also have to offer a case study, or have to offer, the unbelievers have to offer case studies that support this particular option of why we shouldn't or we cannot always distribute the justified belief through conjunction. So we offer two explanations, both of them linked. The first one was Morrison's argument against idealization and the idealization path, and the second one was lying on holistic properties of models and theories, and we present the Rubik cube metaphor. We also introduced a possible candidate for supporting the ISC thesis, the conflict between atomic nucleus models, and that was all. Thank you very much.
Maria, for wonderful slides.
Thank you.
So one thing which I don't understand is why are scientists just rational or justified to believe these models? How do you get there? So I understand the point that that Morrison speaks of these idealized models and we can't de-idealize them, but how do you get to scientists being justified to believe these models? Morrison is a realist, but I don't think that the thesis of scientific realism has much support, so we would have to be strong realists about models to go there.
Do you want to say something?
Yeah, it's a question.
You should go first.
Well, we were thinking about maybe not necessarily Morrison committed to the scientists were justified believing in the models, but anyone that claims that predictive power, also predictive power, can justify scientists to believe.
I would never go that far. I never said that a good prediction justifies belief in whatever is predicting. I mean, I can have a very good mathematical apparatus which is based on just pure idealizations, but doesn't mean it's a true description of the world. And I think Davy and Vickers would just say...
But what she claims in the book, at least, is that those models, because scientists cannot explain where the success is coming from, and they have no other explanation of why they are working so extremely well. And because of things she has argued in previous chapters about that, she believes that there's a link between reality and models that has been assured by successful models. So those models have linked whatever mathematical apparatus you have to reality in a way that other mathematical apparatus cannot get. And that's something that puzzles her a lot, and she will claim that scientists do believe in that. But
in the link.
In the result of the link, because there is the outer reality that is explained by a mathematical apparatus, for instance, and the mathematical apparatus weirdly does a job that no other mathematical apparatus was doing before. So the result seems to be something that can justify scientists to believe in the link and whatever is linking those two things.
Okay, yes.
Thanks for the talk and the wonderful slides. I love the caricature of Peter Vickers is perfect. So
I'll send it to him. Maybe he will not like it very much.
I thought it was great. So I have a couple of suggestions. Of course, I'm very sympathetic with what both of you are doing. Strategically, however, I think relying on that particular conception of Morrison, it's highly problematic, right? Because in a way, it's the way she's describing scientific practice there assigns a level of disinformation from the practitioners about their models that seems unjustified, right? So, because it's almost as though she's presenting the situation, oh, the scientists, they have no idea unless they really made up the idealizations. They have no idea what holds in a model, what's not. Mm-hmm. And I think, in fact, they know far more than that. And typically, even in models that are empirically successful, the scientists would refrain from believing in the model if there are concerns about it. So Bohr's model is a beautiful case, right? I don't think Bohr ever believed in the model, right? It worked, beautifully produced the Balmer sequence, and no other model had done that before. However, that didn't give any reason for Bohr to say, yes, I believe in this model, right? So yeah, this is a good model, we got the right results, but they kept looking for something better because there were concerns about what was going on. They knew exactly where those concerns were. So, and I think similarly can be said about the nuclear case that Morrison mentions. I think, of course, there are inconsistencies, right? between these models. That's exactly why the physicists are not going to say, yes, I believe in those things. So my suggestion is this: I think rather than going for the problem of distribution, justified belief over conjunction, I think you can block the argument beforehand. Namely, there's no reason to assign to the community that they have justified beliefs about those models in the first place, even though the models work. Right? So, and in that way, you can actually be a little less committed to that particular description of the practice, which I find, although I love Morrison's work, I think it's highly problematic.
I think Luis wanted to say something about that.
Direk wanted to ask something first.
Right.
Okay. No, then she was stressed.
Ah,
Yeah, if Luis want to postpone his question. Okay, so please go ahead. I don't know your name, sorry. Michelle, okay.
It's actually a follow-up.
Yeah.
Great man. Michelle, sorry, go ahead.
And this is, it's just a follow-up, actually. So, I think you're right that both, I mean, Vickers begs the question with respect to notions of rationality, with respect to belief attribution. Morrison just falls into the belief attribution trap, right? It's not belief, right? So all that should just be, you see, you can be much more sophisticated than Morrison is. Yes. And so, and furthermore, what you might want to claim too is, it is a little bit like your Rubik's Cube, that when it is that you can't distribute over conjunction is when you have mixed, this is the hypothesis, when you have mixed falsehoods and true reality things insofar as you can at all, or insofar as you can disentangle those. It might be in those cases that you can't distribute over n. You know, so that might make something much more precise than what Morrison is saying, and would just make a much more sophisticated thesis than Morrison is. So it's just a
Thank you
comment.
for that. Thank you for that.
Okay, Luis, is your turn?
Oh,
Sorry.
Okay.
I'm sure I can.
Okay.
My reaction to Vickers' work in particular is that this is kind of a Trojan horse to talk about belief. Because as Fabio says, that these scientists, it's a stretch to say that scientists believe this. They believe there was something to it. That's a different thing. They certainly believe that.
Or they got excited about it.
Yeah, very excited. And very few said there's nothing to it. Right. They sort of fell by the wayside. But the point isn't whether or not you believe in inconsistent things. The point is that you're working with inconsistent commitments and you're reasoning with them, and you have to be reasoning in a way that doesn't give you trivialization. And for me, that was always the problem. I've never been one of Graham's followers in the matter of radical inconsistency tolerance. But that is a real problem. How do we reason? How do we control and restrict the conclusions that we reach, given what we normally take to be the case about how logic tells us to reason? What sorts of commitments come with these statements? And it's not just, oh, well, I just think it's an approximation. I think Morrison's right about that. You can't just be dismissive about it because these things are not easily disentangled. And that still doesn't solve the problem of reasoning.
Right.
Okay, do you want to answer something to that?
I don't know, I thought you had something to say, and Natalia was.
No, no.
Okay, yes.
I have something to say.
I already wished. There is a lot to say. Just that this problem of about how do we reason from inconsistent assumptions starts from the fact that there are inconsistent assumptions, right? But that's precisely what Vickers is challenging.
So, but that's this Trojan horse of saying, you know, don't take what scientists actually wrote down and calculated with seriously, right? Instead, impute to them some indescribable state of belief, right, which you can't cash out in terms of language that they had. And then say, but that would have been consistent, and say, therefore there's no inconsistency in science. I think
That's
that's
what
just
then
a
you
cheat.
beg, you just beg the question, because you say it has to, a priori it has to, then
Yeah,
it's
exactly,
consistent.
because that's part of the
Otherwise, it
background
can't be
theory of what
reasonable.
beliefs are like.
Right, and that was just a question.
It's a cheat. And what you have to look at what they wrote down. If they wrote down things that seem to add up to inconsistency, and yet they managed to reason with it, then you have to ask yourself, how did they do that?
And reconstruct it.
Right. Well, I think in fairness to him, he also tries to consider what would be the formulations of these theories in a way that inconsistencies are not involved. Right? And he tries to do a little bit of that kind of cleaning up, which is that's the sort of first order
Which
level.
is fine, right.
And so you can-
Methodologically, it's fine.
Right.
But, but when you're left with the inconsistency that you can't tidy up, then
That's
you're
right.
still going to have to do some
Oh, yeah.
reconstruction that still makes it coherent. Unless you, I mean, what is gained by attributing to a scientist that he's irrational? Nothing. Nothing is gained by that.
Oh, I
Okay,
disagree.
Diederik, sorry.
I mean, honestly.
Okay, first Diederik,
It might be
sure.
The question I had is more or less related to what was said before. Dunia and Christian, but I think it was Dunia organized a workshop with Peter Vickers. It was very interesting. But I think what I thought was the main problem in his argument, as I heard it there and reading large parts of the book and then discussing with him and so, is that I would agree immediately that scientists in the past, and maybe not all of them in the future, as soon as they found an inconsistency, look for a way to get rid of it. And I think this is very good. And that because this will lead to something better. Where I think Peter argues or has a very strange argument is that he seems to think, and he admitted that he did, we did not have many beers at the moment, so he was serious about it. So he seemed to think that you can only get to wrong conclusions through expulsive quote-liberty after, I should not phrase it like that. You can only get to conclusions that shouldn't follow after you reach the inconsistency. And of course, this is a mistake, because if you don't know that there is an inconsistency, you will have all kinds of conclusions and then applying transitivity, derive all kinds of stuff that is absolutely nonsensical and that comes to an application of expulsive quote-liberty if you reconstruct it decently. But scientists cannot see that, and we cannot see it. And so I think the problem is not so much that people try to get rid of the inconsistency, because I think that is very good and decent and methodologically all right. But the problem is indeed that before that, how do they reason at the moment that they didn't get rid of the inconsistency? They realized that there is a problem, and then what did they do? And of course, then I agree completely with what was just said before.
Okay, do you?
No, it was just a remark on this. I don't think it's problematic, that nothing is gained by asking if scientists are rational in the way they do science, because they may very well be irrational. I mean, that's why we have normative methodological approach, because they might be, for instance, rejecting a useful theory, or they might be accepting an inconsistent set of premises without realizing that, and then we pinpoint that they are just wrong in this situation. So
We can
that-
name names.
Okay, no, that,
Yeah.
no, that's right, I accept that.
So in that sense, I
Right.
just would.
But they don't gain, but Vickers doesn't gain what he wants to gain by calling them irrational.
Yeah,
It's more that there's a corrective mechanism within science.
He actually thinks nobody was irrational because nobody believed in consistency. So he just says, well, there is no problem.
It's
There
a
are
whitewash.
Yes, and the main problem is that these instrumental commitments,
Okay.
which you mentioned, are not taken for him to be examples of commitment to inconsistent science. So he just dismisses this. Well, these are idealizations, but he doesn't show why these are not interesting cases for us to also take as examples.
Yeah, and he seems to have the idea that you cannot make a case for prior consistency unless you assume that scientists believe their inconsistent proposals or their inconsistent theories or their inconsistent models. And I had the impression that you are more or less following this also here a bit in your talk. And I think many people here, or several people here would disagree that we can make a case for the need of prior consistency without assuming that scientists believe in their inconsistent models.
Mm-hmm.
And also most of the examples that I know from the list, I would agree with Diederik. As soon as they see it, well, they start looking for something better.
Right. So this is also consistent with the discomfort that they might feel with the inconsistency. The fact that they don't even believe in it.
Yeah.
Right? Even if you don't believe in something, you can still feel that discomfort and be searching for something else. So belief is a non sequitur.
I think that search involves reason with it.
Right.
In a
Exactly
non-trivial
right.
way.
Exactly right.
Okay, Moises.
Okay, so I have a question about the dialectic for all of you, which are having this body discussion. So you claim that what is important is to explain how you can reason with inconsistent theories. That seems to be like the important problem, right?
I don't think it's the only thing, but it's the thing that I've focused on.
But part of the dialectic here was, I guess, to Victor's point was to say, well, since there are no inconsistent, since you can show that no one actually believed in an inconsistent theory, then the problem that you're claiming is the most important one in this context doesn't arise. If you grant that assumption, which then you don't get that problem, right? So the point I was trying to make was that the argument here seems to be going against the idea that you have to grant that assumption, right? So, and then Otavio suggested that well, look at how scientists actually reason in their practice, and you can see that you can put a stop to this before even going to justify belief, because you can say, well, look, in the Bohr model, etc., no one actually believed this stuff. Well, it doesn't seem to me that you need to actually be committed to the notion that every scientific model is one that scientists justifiably believes. And you don't even need, in this case, you don't even need any commitment to believe in scientific realism or scientific truth, because the notion that the rule that's playing an important role here is just the rule that if you're justified in believing something, which goes along with the notion that you said about scientists believe there's something going on here. If you believe that there's something going on in some theory, then you're justified in believe there's something going on in some parts of the theory. That seems to be the rule that Vickers is using in order to argue against the notion that there are that scientists believe in inconsistent theories. So it seems to be a good idea to then say, well, but even if you grant all of that, then you cannot go from the assumption that you're justified in believing that there's something going on here to the consequence that you're then justified in believing that there's something going on in this part, and you're justified in believing that there's something going on in the complement of that part, right? So, so even if what you claim is true, then if this works in the context of showing that entailment doesn't hold, then that seems to be a good strategy. And I think that this has there's an advantage to this point, which is an advantage to Otavio's point, because what he says is, okay, so how does scientific practice work, and what do scientists believe? But that seems like it would require to do some empirical psychology or some statistical study and go around and ask scientists, okay, so how do you behave in the context of these theories? And you don't need to do that, because if this works, because in this case, then you just can show that you can get the entailment, and that will be enough to defeat Vickers' argument. So that was all.
But I think the main problem with this argument is that the notion of justified belief is not at all what any epistemologist or even philosopher of science would be ready to agree with. It's just justified belief is extremely strong notion. It has to do not just with something being predictively accurate. It's really having evidence together with a lot of cognitive values to accept this as empirically successful model, and then you say, I'm justified to believe that this is really very, very strong epistemically loaded notion. So this is where the problem comes. Even if Vickers, to make this statement, if you want to speak of justified belief, this is it's such a heavy term to use for that. And if you are using this term, you have such a strong burden of proof. That's, I think, the problem.
Okay.
Yeah, Michelle, that's
Michelle, yes.
So
what
it's
is-
just a suggestion. What if we soften the notion of justified belief to, we work with this model? Right? That everybody,
Problem solving do?
will the argument still go through? That's the question. Either of Vickers or of Morrison.
yes.
So we've been, so you're right to question dialectic, right? So we've been sort of fixing on this notion of justified belief as being too strong, but even if you soften it to, it seems to be a temporary solution, or we happen to be working with, or we happen to be excited by, or.
My talk will be about different notions on that.
So there's no reason to believe that those distribute over conjunction.
Good,
Right?
oh, good, okay, good. So that's what the softening does for you, is it stops our thinking that we can distribute over conjunction. Is that right? Because you're gonna keep talking. Okay, so that,
Because that's your talk.
so that might be that's
Still
very
give you a
nice
talk?
of it.
I don't know, maybe it's not needed.
So that's very nice, so.
Yeah,
You can take that.
yeah, one comment is, when I suggest looking at scientific practice, of course, I'm not suggesting doing surveys of what scientists believe or not. What I have in mind is engaging as philosophers of science and people who do, science studies, understanding the practice in its own terms. What is it? What kinds of inferential processes are going in the practice, right? And I think that's an important task of anyone who's doing philosophy of science. Understand science, right? Understand the way that the science is done. And that's another reason why justified belief is entirely irrelevant, right? It's not the kind of category that illuminates the practice should begin with, right? So, and then the concern I had was, in order to block the distribution of justified belief over conjunction, then you need to settle on a particular understanding of the practice that it's more. And that's, I think, it's problematic, because then your argument relies on what she's saying being right. And anyone who challenges that will say, well, then your argument doesn't go through. So it'd be nice if you can make the point independent on what is an interesting but problematic account of the practice.
Okay, does anybody else wants to talk? Because we seem to have reached a kind of consensus, I think.
You justifiably believe in a
Okay, in that case, I propose we thank again Maria for the talk. There's still some biscuits and coffee outside, so.
And see you tomorrow at 10 a.m., everybody. Otavio will be the first one, and then Dunya, and then Philo. Yes, so you have to wake up very early.
All right, I better be on time.
So it's-